Morning, everyone. This video, we're going to talk about the idea of forecast performance error again, but how to evaluate it using the appropriate metrics. So we've got different ways of measuring error. Some of the more common ones are bias, cumulative forecast error, mean forecast error, mean percent error, mean absolute deviation, mean absolute percentage of error, demand filters, tracking signals, standard deviation. The above are all various ways to mathematically measure error. Fortunately, we're not required to know each of them in depth, but the formulas as found in the participant guides and the reference manuals are good enough. But to me, it's always been a kind of like defining the term average and what do we mean by mean, median, and mode. Mean's the mathematical average, median's the middle, mode is the most common. And it feels like there's the same thing with forecast errors. How do we take out the impact of the pluses or minuses washing each other out? And where mean absolute deviation looks at ignoring the sign, the absolute value, standard deviation uses a form of squaring and taking the square root. So each method typically will address it from a different perspective. Do we want to look at it by a value or percentage as well? To what level of mathematical precision do we need? But the challenge there could be maybe it's not understandable, or is it just close enough, is what we run into. So it really becomes important to use the measure that most closely accomplishes the balance of precision and accuracy so that most folks will accept it and use it in their work. And the impact ultimately becomes users can validly understand the forecast, but the range of variation and acceptability, and therefore make informed decisions at the same time.